Good evening, and welcome. As the world outside settles into its quiet rhythm, and the stars begin to emerge in the deepening twilight, we invite you to embark on a journey not through the bustling corridors of space agencies, nor through the well-trodden paths of celebrated missions, but into the hushed corners of discovery. Tonight, we will listen closely to the universe's most subtle pronouncements, to the whispers from the void that reshaped our understanding, yet often remained just beyond the spotlight. These are the forgotten stories, the quiet epiphanies, the moments when NASA scientists, often alone in the late hours, stumbled upon truths so profound they felt less like findings and more like secrets entrusted to them by the cosmos itself. What if I told you that some of the most monumental shifts in our cosmic perspective weren't announced with fanfare and flashing lights, but were instead born from a single, almost imperceptible flicker on a screen, a faint anomaly in a sea of data, or a quiet realization in the dead of night? What if the universe doesn't shout its grandest revelations, but rather it murmurs them, waiting for the quietest, most observant minds to lean in and hear? Tonight, we delve into these whispers. We will explore the silent, often overlooked moments that unveiled a universe far stranger, far more active, and infinitely more mysterious than we ever dared to imagine. From a moon that screamed its existence across millions of miles, to an interstellar visitor that defied all logic, to flames that burned invisibly in the vacuum, these are the tales of unexpected beauty, unsettling questions, and the profound humility that comes with truly listening to the cosmos. And perhaps, as we journey through these hidden narratives, we might even touch upon the most profound whisper of all, the subtle, persistent hint that we are not alone in this vast, silent expanse. Not in the way of flashing lights and alien encounters, but in the quiet, scientific pursuit of life's fundamental building blocks, found in the most improbable places, urging us to reconsider everything we thought we knew about where and how life might thrive. Our first whisper takes us back to a cold, sterile room at NASA's Jet Propulsion Laboratory in Pasadena, California. The year is 1979. The air is thick with the hum of computers and the scent of stale coffee. Outside, the world sleeps, but inside, a small team of scientists and engineers are wide awake, their eyes glued to flickering screens, awaiting the first close-up images from Voyager 1, a tiny metallic emissary that had traveled for years across the vast emptiness, now approaching Jupiter, the solar system's colossal monarch. Among them is Linda Morabito, a navigation engineer. Her job is meticulous, almost tedious, to precisely measure the positions of Jupiter's moons against the backdrop of distant stars. These measurements are critical, allowing mission control to fine-tune Voyager's trajectory, ensuring it hits its precise target. It's a task that requires immense focus, an unwavering eye for detail, and a profound patience for the slow, deliberate dance of light and shadow. Hour after hour, Linda pores over the black and white images, each one a mosaic of pixels, slowly painting a picture of a world unseen. The images arrive in segments, transmitted across hundreds of millions of miles, painstakingly reassembled by the computers. On this particular night, she's examining images of Io, Jupiter's innermost large moon. Io is a peculiar world, known for its vibrant, mottled surface, a testament to some unknown geological activity. But no one, not a single soul on Earth, suspected the true extent of its fury. Linda adjusts her chair, her eyes scanning the familiar crescent of Io illuminated by the distant sun. She's looking for stars, tiny pinpricks of light that will serve as her celestial benchmarks. But then, something catches her eye. A faint, crescent-shaped smudge, almost imperceptible, clinging to the limb of Io. Just beyond the terminator, the line separating day from night, her internal monologue begins, a quiet conversation with herself, a scientist's instinct kicking in. Something's off, she thinks, her brow furrowing. That crescent, it shouldn't be there. It's too bright, too distinct for a star. She checks her star charts, cross-references her data. No known star should be in that exact position, with that specific shape. It's not a star. It's not a cosmic ray artifact, a common glitch in early digital images. It's something else. Something real. She zooms in, pixel by painstaking pixel. The smudge resolves into a plume, a distinct umbrella-shaped cloud rising from Io's surface, illuminated by the sun from behind. It's a sight that defies all expectations. For decades, scientists had believed that the outer solar system was a frozen, geologically dead realm. The inner planets, yes, they had volcanoes. Earth was alive. Mars showed signs of ancient activity. But Jupiter's moons, they were supposed to be inert, icy spheres. Linda calls over her colleagues, her voice a hushed whisper, almost reverent. "Look at this," she says, pointing to the screen. The room falls silent, save for the gentle hum of the machines. One by one, their eyes widen. Disbelief gives way to a stunned realization. What they are witnessing, captured in a single, grainy photograph, is an active volcanic eruption. Not on Earth, not on a terrestrial planet, but on a moon of Jupiter. This wasn't just a discovery, it was a revolution. It meant that tidal forces from Jupiter, the colossal gravitational tug-of-war, were generating immense heat within Io's core, melting its interior and spewing its guts into space. Io was not just geologically active, it was the most volcanically active body in the entire solar system, a cosmic pressure cooker constantly reshaping itself. The implications were staggering. If Io, so far from the sun, could be heated by internal forces, what about other moons? What about Europa, another of Jupiter's Galilean moons, known to harbor a vast subsurface ocean beneath its icy shell? If tidal forces could power volcanoes, could they also power hydrothermal vents at the bottom of a European ocean? And if so, could those vents provide the energy and chemicals necessary for life? This quiet, accidental discovery by Linda Morabito wasn't just about volcanoes. It was a whisper from the cosmos, hinting at the vast, unexpected possibilities for life beyond Earth. It opened up an entirely new paradigm for astrobiology, shifting our focus from just Mars to the tantalizing prospect of icy ocean worlds, where life might thrive in perpetual darkness, warmed by internal fires, completely independent of the sun. It was a profound moment, a silent turning point in our understanding of where life might exist, born from a single, unexpected crescent on a distant moon. And so, the universe continues to whisper its secrets, often in the most unassuming moments, to the most unlikely ears. These are the stories of those whispers, and the quiet minds who heard them. Part 1. Io's Cry, A Moon Awakens, 1979. Let us linger a little longer on Io's awakening, for it is a foundational tale in the tapestry of NASA's unknown stories. The Voyager 1 spacecraft, launched in 1977, was a marvel of human ingenuity, a robotic explorer designed to provide the first detailed close-ups of Jupiter and Saturn. Its journey was long, its instruments precise, but no one could have predicted the drama it would capture. Linda Morabito's role as a navigation engineer was crucial, yet often behind the scenes. She wasn't a planetary scientist, not primarily. Her expertise lay in the precise mathematics of celestial mechanics, ensuring Voyager's trajectory was perfect. This made her discovery even more poignant. It was an anomaly, caught by an expert in precision, not by someone specifically looking for geological activity. The images arrived slowly, byte by byte, over the deep space network. Each pixel was a precious commodity. Linda would spend hours, sometimes days, meticulously examining these raw data streams. On that fateful March day, as she processed images taken just hours before Voyager's closest approach to Io, the anomaly appeared. It was small, a mere speck, but its persistence across multiple frames, its distinct shape, and its position relative to Io's limb screamed real. Her initial thought wasn't volcano. It was, what is that? The scientific consensus of the time dictated that such activity was impossible on a moon so far from the sun. The prevailing theory was that moons in the outer solar system were cold, inert bodies, remnants of the solar system's formation, long since cooled to their cores. Io, with its peculiar colors, was an enigma, but certainly not a hotbed of geological fury. When Linda presented her findings to her colleagues, there was a moment of stunned silence, followed by a flurry of activity. Other scientists, geologists, and planetary experts rushed to verify her observation. They cross-referenced data, ran simulations, and examined every possible explanation for the anomaly. But every test confirmed it, a plume of material, hundreds of kilometers high, erupting from Io's surface. The scientific breakdown of what they were seeing was revolutionary. The plume was likely composed of sulfur and sulfur dioxide, ejected at incredible speeds. The energy source, they quickly deduced, had to be tidal heating. Jupiter, with its immense gravitational pull, constantly stretches and squeezes Io as the moon orbits. This continuous kneading generates friction deep within Io's interior, creating immense heat, far more than any radioactive decay could produce. This heat melts rock, creating vast magma chambers that erupt through the surface. The discovery of Io's volcanism fundamentally altered our understanding of planetary geology. It proved that worlds could be geologically active, not just through internal radioactive decay, but through external gravitational forces. This opened up a new avenue of thought. If tidal forces could heat Io to such an extreme, what about other moons? Could Saturn's moon, Enceladus, with its geysers of water ice, be powered by similar mechanisms? Could Jupiter's Europa, with its speculated subsurface ocean, harbor hydrothermal vents, providing chemical energy for potential life? The aftermath of Io's cry was a quiet revolution. No longer could scientists assume that distant, icy worlds were barren and lifeless. The universe had whispered a profound truth: energy, and therefore the potential for activity and even life, could be found in the most unexpected places, driven by forces previously underestimated. Linda Morabito, the navigation engineer, had not just found a volcano. She had inadvertently opened a new chapter in the search for life beyond Earth, a chapter that continues to unfold with every new mission to the outer solar system. The silence from the stars, once assumed to be the silence of death, now seemed to hold the promise of hidden vitality. Part 2. The Object. We never meant to find the accident. 2021. Our next whisper takes us to a more recent past, to the year 2021, and to the realm of the truly bizarre. Imagine a star, not burning brightly with the fury of a sun, but merely glowing with the faintest embers of its birth. Now imagine that star, not bound by the gravitational embrace of any galaxy, but hurtling through the cold, dark emptiness of intergalactic space, a cosmic rogue. This is the story of an object we never meant to find, an accidental discovery that hinted at a hidden population of celestial wanderers. The Wide-Field Infrared Survey Explorer, or WISE, later reactivated as NEOS, is a space telescope designed to scan the entire sky in infrared light. Its primary mission is to detect asteroids and comets, especially those that might pose a threat to Earth. It's a diligent, tireless observer, constantly mapping the infrared universe, revealing objects too cool or too distant to be seen in visible light. In 2021, as astronomers sifted through years of NEOS data, a peculiar signature emerged. It was a faint, red glow, moving across the sky at an unusual velocity. It didn't fit the profile of a typical star, nor a distant galaxy. It was too cold to be a star like our Sun, yet too warm to be a mere planet. It was, in essence, a brown dwarf, a failed star, too small to ignite sustained nuclear fusion in its core, yet larger than a gas giant planet. But this brown dwarf was different. Its trajectory suggested it wasn't orbiting our galaxy. It was moving too fast, in a direction that indicated it was an interloper, a visitor from beyond the Milky Way. This was a truly rogue object, unbound by any galactic gravity, drifting through the vast cosmic ocean between galaxies. The astronomers tracking it engaged in a conversation filled with a mixture of awe and bewilderment. It's cold, one might have mused, but glowing. How? The glow came from its residual heat, the last vestiges of the gravitational collapse that formed it, slowly radiating away into the absolute zero of intergalactic space. And where did it come from? Another might have wondered. The most plausible explanation was that it had been ejected from its home galaxy millions or even billions of years ago, perhaps during a chaotic galactic merger or a close encounter with a supermassive black hole. This discovery, almost an accident in the grand scheme of NEOIS's asteroid hunt, sparked a wave of speculation. If one such rogue brown dwarf could be found, how many more were out there? The universe is vast, and the space between galaxies is even vaster. Could there be a hidden population of these ancient galactic relics, silently drifting through the cosmic darkness, far from any star or galaxy? The haunting idea began to take root. A universe populated not just by galaxies and stars, but by countless, unseen, cold, and lonely wanderers. These would be the true ghosts of the cosmos, remnants of long-dead star systems, carrying the echoes of ancient galactic histories. They would be incredibly difficult to detect, their faint infrared glow easily lost in the cosmic background noise. The accident of finding this rogue brown dwarf was another whisper from the void, suggesting that our maps of the universe are far from complete. It hinted at a vast, unseen component of cosmic mass and a dynamic, violent past for galaxies that could eject entire stars into the intergalactic abyss. It was a reminder that even in the seemingly empty spaces, there are secrets waiting to be unveiled, silent travelers carrying untold stories across the eons. And perhaps, in the deep cold of some of these rogue objects, conditions might even exist for exotic forms of chemistry or even life to persist in ways we can barely comprehend, far from the warmth of any sun. Part-3, Oumuamua, the visitor that came and left too soon. 2017. Our journey through NASA's whispers continues with a tale that captivated the world, yet left us with more questions than answers. In 2017, the Pan-STARRS telescope in Hawaii, designed to scan the night sky for near-Earth objects, spotted something truly extraordinary. It was a faint, fast-moving speck of light racing through our solar system at an incredible speed. Its trajectory was unmistakable. It wasn't orbiting the sun. It was an interstellar visitor, the first ever confirmed object from another star system to pass through our own. Its name was Oumuamua, a Hawaiian word meaning a messenger from afar, arriving first. And a messenger it was, though its message remained tantalizingly obscure, as astronomers around the globe scrambled to observe it before it vanished back into the interstellar void. A detailed visual description began to emerge. It was unlike anything they had ever seen. Estimates suggested it was roughly 400 meters long, incredibly elongated, shaped like a cosmic cigar or a flat pancake, and it was tumbling end over end as it sped away from the sun. Its eerie silence was perhaps its most striking feature. No visible tail, no coma, no outgassing. Unlike any comet they knew, it didn't behave like an asteroid either, which would typically be rounder and follow a more predictable path. It was a mystery wrapped in an enigma, a silent, dark traveler from another star system, giving us only the briefest glimpse of its form before disappearing forever. The scientific debate over its nature was immediate and intense. Was it a rock, a chunk of ice, or was it something more? One researcher, his voice a hushed whisper filled with professional awe, might have said, "It didn't behave like anything we've ever seen." This was the core of the puzzle. The most perplexing aspect of Oumuamua was its unexpected acceleration. As it left the solar system, it sped up slightly, as if being gently pushed by some unseen force. Comets accelerate due to outgassing, as ice turns directly into gas, acting like tiny thrusters. But Oumuamua showed no signs of outgassing. This anomaly led to wild speculation, even from respected Harvard astronomer Avi Loeb, who famously suggested it could be an artificial object, a piece of alien technology, while most scientists ultimately leaned towards a natural explanation, perhaps outgassing of some exotic invisible ice or a peculiar shape interacting with solar radiation. The debate highlighted the sheer strangeness of the object. Oumuamua was a cosmic anomaly that forced us to confront the limits of our classifications. It was a whisper from beyond our immediate cosmic neighborhood, a fleeting glimpse of the vast, unknown population of objects that must be traversing the galaxy. It was a reminder that our solar system is not an isolated bubble, but a permeable membrane constantly interacting with the interstellar medium, receiving visitors from unimaginable distances. Its brief, bewildering visit left us with a profound sense of wonder and a lingering question. If this was just the first interstellar object we detected, how many more have passed through our solar system unnoticed throughout cosmic history? And what secrets do they carry from their distant homes? Oumuamua was a silent, enigmatic messenger, or intelligence, to manifest in forms we are only just beginning to conceive. It was a whisper of the truly alien, a reminder that the universe is far more inventive than our wildest dreams. Part 4, The Flame That Didn't Burn, Flex on ISS 2008 to 2014. Our next whisper takes us not to the vastness of interstellar space, but to a confined, metallic laboratory hurtling above Earth at 17,500 miles per hour, the International Space Station. Here, in the microgravity environment, the laws of physics behave in subtly different, often counterintuitive ways. And it was here that scientists stumbled upon a phenomenon so strange it challenged our very understanding of fire. The experiment was called FLEX, the Flame Extinguishment Experiment, and later FLEX-2. Its purpose was deceptively simple: to study how flames behave in microgravity. In space, without gravity, convection doesn't occur. Flames are spherical, burning uniformly outwards. Understanding combustion in space is crucial for spacecraft safety and for developing more efficient engines on Earth. In the specialized combustion integrated rack aboard the ISS, astronauts would inject tiny droplets of fuel, often heptane, a common hydrocarbon, into a chamber and ignite them with a hot wire. The cameras would record the spherical flames. As the heptane droplet was ignited, a small, spherical flame appeared, glowing with a familiar orange hue. Or so they thought. The whispery retelling from the scientists involved speaks of a moment of profound confusion, then dawning realization. They reviewed the high-speed camera footage, frame by frame. The visible flame, the bright, hot part, indeed disappeared. But the instruments, sensitive to infrared light, still registered heat. And then, in the images, a faint, almost imperceptible glow persisted. "It's still burning," one scientist might have murmured, his voice filled with disbelief, "but we can't see it." This was the discovery of cold flames or cool flames in microgravity. On Earth, these cold flames are fleeting, unstable phenomena, quickly extinguished by convection. But in space, without the disruptive forces of gravity, they could persist for minutes, sometimes even longer. These flames burn at much lower temperatures, around 200 to 300 degrees Celsius, compared to the thousands of degrees of a normal flame. They produce very little light, primarily emitting in the infrared spectrum, making them almost invisible to the naked eye. The explanation of cold flame chemistry is fascinating and complex. Normal flames produce soot and carbon dioxide. Cold flames, however, involve a different, low-temperature oxidation process. They produce carbon monoxide and formaldehyde, and they consume fuel much more slowly. This discovery has profound implications. For one, it means that fires in space might not always be visible, posing a silent, invisible threat to astronauts. It also opens up new avenues for developing more efficient, low-emission combustion engines on Earth. By understanding how to harness these cool burning reactions, the flame that didn't burn, the invisible fire on the ISS, was another whisper from the void, or rather, from the microgravity environment. It was a reminder that even the most fundamental processes, like combustion, can behave in utterly unexpected ways when removed from the familiar constraints of Earth. It highlighted the universe's capacity for subtle, hidden phenomena and the importance of pushing the boundaries of our experiments to reveal truths that lie just beyond our immediate perception. It was a silent, glowing testament to the fact that even in the most controlled environments, the cosmos holds surprises. Part 5: The Hubble Ghosts, Hidden Dwarfs in the Darkness. Our next whisper takes us back to the grand observatory that has redefined our view of the cosmos, the Hubble Space Telescope. For decades, Hubble has delivered breathtaking images of distant galaxies, nebulae, and star-forming regions. But sometimes, its routine observations reveal something far more subtle something that hints at a vast unseen population lurking in the cosmic darkness. This is the story of the Hubble ghosts, the discovery of ultra-cold, ancient brown dwarfs, quietly drifting through the galactic night. The search for brown dwarfs has been a long and challenging one. These failed stars, as we discussed earlier, are too small to sustain nuclear fusion like true stars, but too large to be considered planets. They occupy a mysterious twilight zone between stars and planets, emitting very little light and heat. They are, by their very nature, incredibly difficult to detect. Hubble, with its unparalleled sensitivity, has been instrumental in this hunt. Its routine starfield observations, often targeting clusters or specific regions of the Milky Way, sometimes capture unexpected light curves. These are not the dramatic flares of distant supernova, nor the rhythmic dimming of exoplanets passing in front of their stars. Instead, they are subtle, almost imperceptible shifts in brightness, hinting at something cold and faint. The discovery of ultra-cold, ancient brown dwarfs by Hubble was a painstaking process involving years of sifting through data, looking for these elusive signatures. These are not the relatively warm brown dwarfs that glow faintly in infrared. These are the truly cold ones, sometimes with temperatures barely above room temperature, emitting almost no light at all. They are the cosmic equivalent of embers that have long since cooled, yet still retain a faint, residual warmth. The narration suggests, what else waits in the dark? This question is central to the mystery of these Hubble ghosts. If these ultra-brown dwarfs exist, and Hubble can only detect the closest and brightest of them, how many more are out there? They could represent a significant portion of the missing mass in our galaxy, a vast population of unseen objects contributing to the galaxy's gravitational pull, yet remaining invisible to our telescopes. These ancient brown dwarfs are thought to be billions of years old, remnants of the early universe, quietly cooling and fading over cosmic time. They are the silent witnesses to galactic evolution, revelation, built upon years of careful observation and meticulous data analysis. The Hubble ghosts are another whisper from the darkness, a reminder that the universe is filled with unseen inhabitants. They challenge our assumptions about the composition of galaxies and the prevalence of different types of celestial bodies. They force us to consider the vast unseen majority, the quiet background hum of the cosmos, made up of objects that are too faint, too cold, or too distant to easily reveal themselves. And in their silent presence, they pose a profound question. What other forms of matter, what other cosmic entities, are quietly shaping the universe around us, just beyond the reach of our current instruments? The darkness, it seems, is far from empty. Part 6. The James Webb Surprises 202-2025 from the Venerable Hubble. Launched in late 2021, JWST was heralded as humanity's most powerful eye on the cosmos. Designed to peer back in time to the very first galaxies, to witness the universe's infancy, the setting was one of immense anticipation. Scientists around the world awaited the first light from Webb, eager to confirm their cosmological models and perhaps fill in some gaps in our understanding of the early universe. The hook for this story is almost too dramatic to be real, yet it was the quiet, stunned realization of many astronomers. This galaxy shouldn't exist. When the first deep cosmic background images from Webb began to arrive, they were breathtaking. Galaxies, billions of light-years away, appeared with stunning clarity. But among them were objects that defied all expectations. Webb saw luminous galaxies, fully formed and surprisingly mature, existing at a time when, according to prevailing cosmological models, they simply shouldn't have been there. These galaxies were observed at redshifts corresponding to just a few 100 million years after the Big Bang, a mere blink of an eye in cosmic terms. Theory suggested that at such an early epoch, galaxies should be small, chaotic, and still in the nascent stages of formation, not large, bright, and well-structured. This discovery sparked an intense discussion of time, light, and cosmic evolution. If these massive galaxies formed so quickly, it meant that star formation processes in the early universe were far more efficient, or perhaps entirely different than previously thought. It challenged the standard model of cosmology, particularly the timeline for galaxy formation. Were there unknown mechanisms at play? Was our understanding of dark matter and dark energy, which dictate the universe's expansion and structure formation, incomplete? The Webb surprises were a profound whisper from the very dawn of time. They suggested that the universe got off to a much faster start than we had imagined. It was as if we had opened a history book to the first chapter, expecting to see a blank page or a few scribbled notes, only to find fully illustrated, complex narratives already unfolding. The implications were vast. It meant that the first stars and galaxies might have formed even earlier than predicted, perhaps within the first tens of millions of years after the Big Bang, in a period often referred to as the cosmic dawn. It also hinted at a potential need to revise our understanding of the initial conditions of the universe, or the properties of the very first stars, which would have seeded these early galaxies with heavier elements. The James Webb Space Telescope, in its very first year of operation, delivered not just beautiful images, but profound cosmological puzzles. It was a whisper from the deep past, urging us to reconsider our timelines, to acknowledge the universe's astonishing capacity for rapid evolution. It reminded us that even our most robust scientific models are always subject to revision in the face of new, unexpected data. The universe, it seems, is always full of surprises, especially when we build instruments powerful enough to truly listen to its oldest whispers. Part 7. Uranus and the Star That Vanished 2024, Our Final Whisper, takes us to the outer reaches of our own solar system, to the enigmatic ice giant, Uranus, often overlooked in favor of its more famous gas giant siblings, Jupiter and Saturn. Uranus holds its own quiet mysteries, and in 2024, a rare celestial event, an occultation, offered a unique opportunity to listen to one of its subtle secrets. An occultation occurs when one celestial body passes in front of another, temporarily blocking its light. These events are invaluable for astronomers, allowing them to study the occulting body's atmosphere or rings with incredible precision. As the light from the background object is momentarily absorbed or refracted, scientists around the world readied their telescopes, from Earth-based observatories to the orbiting Hubble and James Webb. The target, a distant star, predicted to pass directly behind Uranus. As the moments ticked by, the anticipation was palpable. Then, precisely as predicted, the star disappeared. Behind Uranus, the rings of the ice giant, faint and ethereal, glimmered in the background, a silent halo around the planet's ghostly form. But as the star's light dimmed and then vanished, the data flowing back to Earth began to reveal something unexpected. The way the star's light faded and reappeared, the subtle shifts in its spectrum, indicated that Uranus's atmosphere was not as uniform or as dead as previously thought. For decades, Uranus had been considered a relatively bland and inactive planet, a frozen, featureless blue ball. Its atmosphere was thought to be stable, with little of the dramatic storm activity seen on Jupiter or Saturn. The unexpected atmospheric data revealed a more dynamic, more complex Uranus. The occultation data hinted at layered structures, subtle temperature variations, and perhaps even localized weather phenomena that were previously undetectable. It suggested that even this distant, seemingly inert world was undergoing subtle changes, driven by internal heat, or perhaps by the faint energy it receives from the distant sun, the star that vanished behind. Uranus was a powerful whisper from a world we thought we knew. It was a reminder that even within our own cosmic backyard, there are still profound secrets to be uncovered. It challenged the long-held perception of Uranus as a static, unchanging world, revealing a planet with a quiet, yet active, atmospheric life. This discovery, born from a fleeting celestial alignment, underscored the importance of opportunistic astronomy and the power of precise measurements. It showed that even subtle interactions of light and matter can reveal hidden truths about planetary atmospheres, composition, and dynamics. It prompts us to ask, what other subtle changes are occurring on the planets and moons in our solar system that we are yet to perceive? Uranus, the quiet giant, had spoken. Its whisper carried on the fading light of a distant star, told us that even the most seemingly lifeless corners of our cosmic neighborhood hold a quiet vitality, a continuous dance of physical processes that shape and reshape these worlds in ways we are only just beginning to comprehend. The universe, it seems, never truly rests, even in its deepest, coldest reaches, ending silence beyond the known. We have journeyed through the quiet corridors of NASA's history, listening to the whispers from the void, from Io's fiery cry, revealing a universe of tidal forces and hidden energy, to the rogue brown dwarf, a silent traveler hinting at unseen cosmic populations. We pondered Oumuamua, the enigmatic messenger from another star, challenging our classifications and expanding our imagination. We witnessed the invisible flame on the ISS, a testament to the strange physics of microgravity, and the Hubble ghosts, the ultra-cold dwarfs that populate the cosmic darkness. Finally, we peered into the early universe with James Webb, finding galaxies that shouldn't exist, and listened to Uranus, a seemingly quiet giant, reveal its subtle atmospheric life through a vanishing star. Each of these stories, though distinct, shares a common thread. They are reminders that the universe does not shout its secrets, it whispers, and sometimes only the quietest minds, the most patient observers, the most meticulous data analysts, hear it. They are the ones who lean in, who notice the faint anomaly, the subtle shift, the unexpected flicker. These are the moments when our understanding of the cosmos expands, not with a bang, but with a quiet, profound realization. They teach us humility. in the face of the unknown and inspire awe at the sheer inventiveness of nature. They remind us that our knowledge, vast as it may seem, is but a tiny island in an infinite ocean of mystery. As you drift into the quietude of the night, carry these whispers with you. The universe is not a static, fully explored entity. It is a living, breathing enigma, constantly revealing new facets of its being, if only we are willing to listen. The silence beyond the known is not empty. It is pregnant with possibility, filled with untold stories, waiting for the next quiet mind to hear its gentle, profound murmur.